Example 1. Simplify this fraction to get negative sine squared alpha. Okay, we need to think back through some of our hints, and we are going to use the first hint about simplifying. If you're going to simplify something, most of the time that means we distribute and combine like terms because we're trying to get rid of parentheses. But if you have a fraction, instead, when you simplify fractions, you factor and cancel. So we have this fraction, and it's got equations on top and bottom. So let's try and factor it. So I'm gonna write factor as my step. The top, this is an even exponent, a minus sign, and I can square root 1. So I can use the difference of squares here. Remember, difference of squares is if you have something two square rootable terms and they're being subtracted, you can factor it into. You would square root a squared, square root b squared, and then have a plus and a minus. So that can factor that way. We are going to do the same thing here in the top. I can square root cosine to the 4th power alpha. When you square root, it's the same thing as dividing your exponent by 2. So this would be cosine squared alpha and cosine squared alpha. All right, we can square root 1. The square root of 1 is 1. And the pattern here, the difference of squares pattern is you need 1 plus and 1 minus. Okay, so we factored the top part. Notice the bottom has a plus sign in between it. Otherwise, we could have used the square root, the difference of squares pattern, but there's a plus sign here, and you can't factor if there's a plus sign there. So the only other way we could factor this is say, hey, do they have anything in common that we can pull out? No, they don't, so we're stuck there. But if I put parentheses here to make sure I hold that whole thing together, notice the top and the bottom both have a cosine squared alpha plus 1. So step 2, I can cancel like terms. That's the whole point of factoring a fraction. We factor a fraction so that hopefully something will cancel out and make it simpler. That's why you simplify fractions by factoring and canceling. Okay, so that does, when we cancel those two out, we're left with the cosine squared alpha and minus 1. All right, look ahead. This is what we're trying to get to. So we're really close. And whenever you have a mixture of cosine squareds or sine squareds or 1, anything along those lines, you need to try and say, is there a way for me to use the Pythagorean identity? Can I rearrange this Pythagorean identity into this? Can I get a cosine squared minus 1? Well, if I subtract the 1 over here, yay, this is what I want. This is the same thing that I have right there. That's good. But I have to get rid of this sine squared by subtracting it over to the other side. And I will see that cosine squared alpha minus 1 is the same thing as negative sine squared alpha. So if I use the rearranged Pythagorean theorem, I do end up with negative sine squared alpha, which is what I'm trying to get to. So I'm done. Let's do another fraction one so we can practice that factoring and canceling, because I know it's kind of weird trying to factor sines and cosines. All right, so we're going to verify that this fraction equals or simplifies to tangent theta minus 2 secant theta. Okay, that looks like a lot to factor. So if you need to, replace all of your sines with an x and replace all of your cosines with a y. And that's a lot easier to factor. I think most of y'all can factor this pretty quickly in your head, and in the bottom it's only 2 terms, so you either try and square root them, difference of squares, or pull out what they have in common, which is this y term. So if you need to convert these into x's and y's, do that. Just make sure that you keep the squareds where they're supposed to be squareds and numbers, and make sure you have cosine as a separate letter than sine. And once you factor it, you need to convert it back to sines and cosines instead of x's and y's, because this is trig, not algebra. I am going to factor this. All right, I'm not going to leave it like this because you need to start getting used to factoring these types of things. In our next unit, we will do that a lot. Okay, so if I'm going to factor this, there's no number in front of my sine squared, so I need to think, okay, what multiplies to negative 10 and what adds to positive 3? Positive 5 and negative 2. 5 times negative 2? 5 plus negative 2. So good, I factored the top part. Factoring the bottom, I can't square root it. Also, there's a plus sign, so you can't use the difference of squares. But they both have a cosine in them that I can pull out to the front. And if I pull out this cosine, I'm left with my sine theta. And if I pull out that cosine, I'm left with the plus 5. And when you're simplifying fractions, if you need to put parentheses around this cosine, you can do that. So we factored this. The whole point of factoring was so that we could cancel things, or hopefully get something to cancel. And we do. As long as you cancel an entire set of parentheses, which we will be doing, then you're good. So my next step was to cancel to get us to sine theta minus 2 over cosine theta. All right, whenever you have a fraction, you can always break it apart into multiple different fractions as long as you're only breaking apart the top. If there had been like a plus 1 on the bottom here, I could not break it apart on the bottom. But I can break this into multiple fractions or write this as multiple fractions by writing it as the sine theta over cosine theta and the minus 2 over cosine theta. You know, it's kind of the opposite of when we get a common denominator. We're breaking it apart. So as long as you write the whole denominator with both pieces or all the pieces in the top, you can break it into a bunch of different fractions. You cannot break the denominator, but you can break apart the numerator, the top part. And why did I do that? I did that because when I looked up here at my final answer, I had two separate things. It wasn't written as a fraction anymore, and I didn't know what else to do with this fraction. So let's break it apart and see if there's a way, now that it's broken apart, can I convert it to this? And you can, luckily. Sine over cosine is the tangent fraction, the tangent identity. So I always called this the tangent identity. Your Alex homework is going to call it a quotient. So this is tangent, and actually I'm going to just say convert. So I converted this to tangent, and my 2 stays as it is, but 1 over cosine, or 2 over cosine, is 2, and the reciprocal of cosine is secant. So if I convert that, that is what I was trying to get to. Yay, and we're done. In your homework, Alex will call this just algebra. It's not going to be specific. It will say that this is also just algebra. It'll probably also call this algebra. So if in doubt, write algebra, and you're probably good. It will split this up into 2 separate steps. This step will be the quotient step to convert sine over cosine into tangent. And this one will be the reciprocal step, that's the identity, to convert 1 over cosine into secant.